Welcome back to our second session on Vedic math. Last time we laid the groundwork. Today we are going to tackle subtraction, or as it's traditionally known as Vyavakalanam. To fully appreciate the efficiency of the Vedic techniques, we must first examine the limitations of the traditional borrowing method. Let's explore the drawbacks of the conventional subtraction method with the help of an example. So starting from right to left, we subtract the bottom number from the top number and put the answer at the bottom of each column. Since the bottom number 7 is larger than the top number 5, we need to borrow the value from the number which is left of 5. Again, borrowing or regrouping in subtraction is taking one number and giving it to the other number. So here we cross out 4 and then we reduce it by one number, and then we give that 10 to the next number, so making it 15. So 15 minus 7 gives you 8. We are going to regroup again until we reach out to the leftmost digit, which is 2. So here we repeat the process, as I said, until you have completed the subtraction on column. The biggest issue is borrowing. You constantly need to take from the next digit. This becomes messy with multiple zeros. You end up borrowing across several digits, which is confusing and error prone, forgetting to reduce the digit from borrowing, subtracting in the wrong order, losing track in multiple step borrowing. Even a small mistake early would result in a wrong final answer. To overcome these limitations, we can turn to Vedic maths techniques. So before diving into these sutras themselves, let's understand the concept of complements. By using complements, we transform subtraction problems into simple addition problems, making calculations faster and easier. Let's understand the tens complement. Using tens complement, we convert a negative number into an equivalent positive form. This concept is based on place value, where each digit's position determines how the complement is calculated. Decimal number system, also known as base 10, means that each place value in a number is a power of 10. For example, 56 is nothing but 5 into 10 to the power of 1 plus 6 into 10 to the power of 0, which is nothing but 50 plus 6, 56. Again, 7, 6, 5 is nothing but 7 into 10 to the power of 2 plus 6 into 10 to the power of 1 plus 5 into 10 to the power of 0, which is 7 into 100, 700, plus 6 into 10, 60, plus 5 into 1, 5, making it 765. In simple terms, in base 10 system, each place value is a power of 10. 10 to the power of 0, 10 to the power of 1, 10 to the power of 2, and so on. Based on this concept, we can find the complement of a number. The tens complement of of 3 is 7, which means find out the nearest base of 3, which is 10. 10 minus the actual number gives you the complement. Similarly, the tens complement of 9 would be 10 minus 9, since 10 is the closest base to the 9 and 1 is the complement of 9. A simple way to select the base is to count the number of digits in the given number. Then choose a base with the same number of zeros as the digits in that number. For example, the tens complement can be given as 10 to the power of d minus n, where d is the number of digits in the number, n is the number itself. Let's find the tens complement of 76. So 76 has 2 digits. So based on the formula, 10 to the power of 2 minus the actual number, which is 76, gives you 24. For smaller numbers, this method of finding the tens complement is simple and easy to apply. However, when working with larger numbers, it becomes less convenient and harder to follow. This is where the Nikilam Sutra becomes useful, as it helps find the tens complement of larger numbers in a simpler way. Nikilam Navatas Charamam all from 9, last from 10. So to find out the complement of 2, 3, 4, let's say we have 2, 3, 4 and we need to find out the complement of this number. So what we need to do is all numbers starting from the left hand side, we are going to subtract from 9, and the last number or the last digit we are going to subtract from 10. So 2, 3, 4. So 9 minus 2 gives 7, 9 minus 3 6, 10 minus 4 is 6. So 7, 6, 6 is the complement of 2, 3, 4. Let's see another example. 4, 5, 6, 7. Again, we subtract the first 3 numbers from 9 and the last number from 10, which gives 5, 4, 3, 3. So 5, 4, 3, 3 is the complement, tens complement of 4, 5, 6, 7. With practice, finding the tens complement can be done mentally and with ease. Now let's see how to use Nikilam Sutra for subtraction. So with an example, let's take 2, 3, 4 minus 1, 4, 7. So we are trying to subtract 1, 4, 7 from 2, 3, 4. Firstly, the first thing we need to do is identify the negative number, and in this case it's minus 147 is the negative number. And after identifying the negative number, we need to choose the base for the negative number. So here the base of the negative number would be 10 to the power of 3. Since there are 3 digits, 1, 2, 3, so the base would be 10 to the power of 3. Then the next thing what we need to do is find the Nikilam for the negative number. So the Nikilam of the negative number can be found out by subtracting 147 from all from 9 and last from 10. So let's subtract 1, 4, 7 from all from 9 and the last number from 10. So we get 8, 5, 3. So 853 is the Nikilam for 1, 4, 7. Finally, we need to add 2, 3, 4, the positive number, with the Nikilam we just found out, which is 7, 8 and 10. And the last step to conclude to get the result would be subtract the base, which is 1000, from the sum we just calculated, which is 87. So let me go over the steps one more time. The first step would be identify the negative number. So 147 is the negative number, and after identifying the negative number, we choose the base. Again, base is 10 to the power of 3. Since we have 3 digits in 147, our base would be 10 to the power of 3. The second step would be find out the Nikilam of the negative number. So that can be done by all from 9, subtracting the number 147 from all from 9 and last from 10. We get 853 as the Nikilam of 147. After that, we add the positive number, which is 234, plus the Nikilam we just found out, which is 853. Add these two numbers and subtract from we subtract the base from this sum, which gives us 87. 87 is the answer to this problem. We'll just try to strike this off. Borrow a number 7. And then again I strike off this, borrow a number 12 minus 4 is 8. 87 is the answer to this problem. Let's see one more example. Let's subtract 768 minus 495. So here our negative number is 495, which consists of 3 digits. So our base would be 10 to the power of 3, which is 1000. Next step would be find out the Nicolam of the negative number. So which can be done by using Nicolam Sutra. So subtract all the digits from 9 and the last digit from 10. So 4, 9, 5, which gives me 505. So the Nicolam of 495 is 505. The third step would be add the positive number and the Nicolam we just found out. So 13, 7, 12. And the last step would be subtract the base, which is 1000, from the sum we just calculated. So minus 1000, which gives us 273 is the answer for this problem. Let's see one more example. Four, 5, 6, 7, 8 minus 3, 8, 5, 89. So here our negative number is 38589. So it consists of 5 digits. So our base would be 10 to the power of 5 or 1 0 0 0 0 and 1 more 0. Yeah. So this is going to be our base. Then we need to find out the Nicolam for the negative number. So all from 9 and last from 10. 3, 8, 5, 8, 9, which gives us 6, 1, 4, 1, 1. 6, 1, 4, 1, 1 is the Nicolam of 38589, or the tens complement of 38589. The next step would be add the positive number 4, 5, 6, 7, 8 and 6, 1, 4, 1, 1. 9, 8, 0, 7, 10. The next step would be subtract the base, which is 1, 0, 0, 0, 0, 0. When we subtract, we get 7089. So when I subtract 38589 from 45678, I get 7089. If you look at the steps, we have successfully converted a subtraction problem into an addition problem using Nicolam Sutra. What you have just covered falls under case 1. Now let's look into case 2, one positive number and multiple negative numbers. So 445 minus, let's say 38, minus 165, again a minus of 7. So here we have 3 negative numbers and 1 positive number. So for each of the 3 negative numbers, we need to identify or choose the base. So for the first number, minus 38, since they are 2 digits, my base would be 10 to the power of 2 or 100. And for minus 165, it has got 3 digits, so 10 to the power of 3 or 1000. And 7 has a single digit, so 10 to the power of 1 or 10. Now, the next step would be finding the Nicolam for all the 3 negative numbers. For 38, all from 9, last from 10. So 38 gives me a 62. So let me write down all these numbers, 4, 4, 5. Since I'm going to add the Nicolams, I'm going to write the Nicolam here, right here. For 165, it is 9, 9, 10, all from 9, last from 10, minus 165, which gives me 8, 3 and 5, so 835. And finally, I have 7, so 10's complement of 7 is 3, so 10 minus 7 is 3. So I need to add all these numbers, the positive number plus the Nicolams together. So I can use Sudhikaran Sutra, which we learned in the previous class. So we start from bottom up. 3 plus 5 is 8, 8 plus 2 is 10. So 10 is represented as a dot, dot plus 5 is 5. I drop the 5 here. Since there's one drop, one carry. 3 plus 6 is 9, 9 plus 4 is 13, so dot plus 3, 3 plus 1 is 4, 1 dot 1 carry, 8 plus 4 is 12, so dot plus 2, 2 plus 1 is 3, 1 dot 1 carry. So 1, 3, 4, 5. And here coming back to the bases, earlier we had one base, so we have just subtracted the base from the sum, but here we have three different bases. We are going to add all the three bases together, so we get 1110, 1110. So this we are going to subtract from the sum we just calculated, 1110, which gives us 235. So the answer to this problem is 235. Let's see another example. So here again we have three negative numbers and one positive number, 1725, and let's identify or choose the basis for the negative numbers. The very first number is 396, so it has got 3 digits, so 10 to the power of 3 or 1000 is my base, and for 1245 I have 4 digits, so 10 to the power of 4 or 10,000. And for 39 we have 2 digits, so 10 to the power of 2 or 100. Again, the next step would be finding the nicklim for all the negative numbers. So all from 9, last from 10. So all from 9, last from 10 for 396 gives me 604. For the next number, all from 9, last from 10, 1, 2, 4, 5 is 8, 7, 5, 5, and for 39, all from 9, last from 10 gives me a 61. So I have 604, 8, 7, 5, 5 and 61 as my nicklims for all the three negative numbers. The next thing I would do is I'm going to add the positive number with the nicklim. So 604, 8, 7, 5, 5 and 61. So again I'm going to use Sudhikaran Sutra to add these numbers. 1 plus 5 is 6, 6 plus 4 is 10, so dot plus 0, 0 plus 5 is 5, 1 dot, 1 carry, 6 plus 5 is 11, so dot plus 1, 1 plus 2 is 1 plus 0 is 1, again 1 plus 2 is 3, 3 plus 1 is 4, 1 dot 1 carry, 7 plus 6 is 13, dot plus 3, 3 plus 4, 4 plus 1, 5, 1 dot 1 carry, 8 plus 7 is 15, dot plus 5, 5 plus 1 is 6, 1 dot 1 carry. Again, the last step would be adding up all the bases. So we have 10,000, again 1000 and 100. So it's going to be 11,100. So this we are going to subtract from the sum we just calculated. So 11100 gives me 5445. So to the answer to this problem is 5445. So as you can see, we have just converted a negative problem or a subtraction problem into a positive problem using tens complement or the nicklim sutra. So now let's see case 3, wherein we have multiple positive numbers and multiple negative numbers. So let's see an example. So here we have 196, 45 and 170 as three positive numbers, and negative numbers are minus 71 and minus 29. So like before, we just need to find out the base for the negative numbers. So minus 71 has got 2 digits, so 10 to the power of 2, or the base would be 100. And for 29 also, the base would be 100 since they are 2 digits. Now finding the nicklim for all the two negative numbers, all from 9, last from 10, for 71 gives you 29, and similarly for all from 9, apply all from 9 and last from 10 to 29 gives us a 71. So now add all the numbers together, including the nicklims, the positive as well as the nicklims. So 196 plus 29 plus 45 plus 71 plus 170. Starting from bottom up, 0 plus 1, 1, 1 plus 5, 6, 6 plus 5, 15, dot plus 5, 5 plus 6 is 11, dot plus 1, 2 dots, 2 carry, 7 plus 7, 14, dot plus 4, 4 plus 4, 8, 8 plus 2, 10, so dot plus 0, 0 plus 9 is 9, 9 plus 2 is 11, so dot plus 1, 1, 2, 3, 3 dots, 3 carry, 1 plus 1, 2, 2 plus 3, 5. So the total is 511, from which I'm going to subtract 100 plus 100, which is 200. So minus 200 gives me 311. So the answer to this problem would be 311. So this is case 4, wherein we have multiple negative and multiple positive numbers. So here let's look at the case 4, where the negative number is larger than the positive number. So we have 789, which is a negative number, which is greater than 453. So since we have 3 digits, our base would be 1000. So base is equal to 1000. And to find out the Nicolam, we apply the Nicolam Sutra, all from 9, last from 10. So all from 9, last from 10 gives us the Nicolam. So it's going to be 211. Now, as usual, like in the previous cases also, like we're going to add the positive number and the Nicolam, which gives us 664. So previously we were subtracting the base from the sum, but here we are going to do the opposite. We are going to subtract the sum from the base. So 1000 minus 664 gives us a 336. But do not forget to assign a negative sign, because we are subtracting a bigger number from a smaller number. So just add a negative sign. So the answer to this problem would be minus 336. Let's see one more example. 234 minus 7567. So here the base of this number 7567 would be 10000. 4 digits, 4 zeros. And then find out the Nicolam for the negative number, which is 9, 9, 9, 10. All from 9, last from 10. So subtract 7, 5, 6, 7, which gives you 2, 4, 3, 3. So the Nicolam for this number would be 2433. The next thing which we need to do is add 2345 and the Nicolam we just calculated, which gives us 4778. Then the next step would be subtract this 4778 from the base. 10,000 minus 4778 gives you 5222. But don't forget to assign the negative sign. So the answer to this problem is minus 5222. So here, using Nicolam Sutra, we have seen 4 different cases. One, the first case where we are subtracting a negative number from the positive number. Second case, we are subtracting multiple negative numbers from the positive number. Third case, we have multiple positive numbers and multiple negative numbers. And the fourth case would be where the negative number is larger than the positive number. So all this can be done using Nicolam Sutra very easily. Let's learn to perform subtraction using another sutra called the Winklem method, which makes use of Winklem numbers. But what are these Winklem numbers? In a Winklem number, one or more digits are negative, usually shown by a bar over the digit. These are also called the hypothetical numbers because we don't use bar numbers in everyday calculations. So Winklem numbers are also called as bar numbers, hypothetical numbers, and negative numbers. A Winklem number is a number in which at least one of the digit is negative. Let's understand a Winklem number with an example. So 234 is a normal number. So what do I mean by a normal number? I have 2 hundreds, 3 tens, and 4 ones, making it 2434. So when I say a Winklem number, I have a bar over it. Let's say 2 bar 3 bar 4. So the equivalent of this number is, again, it is based on the place value. So I'm going to represent 2 as 2 into 100. A bar number, as I told, it's a negative number. So I'm going to subtract, instead of adding, I'm going to subtract. 3 into, again the place value of 3 is 10, plus 4 into 1. So this is 200 minus 30 plus 4. So the equivalent of 2 3 bar 4 is 174. So each digit, whether positive or negative, keeps its position value. So you simply multiply each digit by its place value and add them together, treating the bar numbers as negative digits as negative values. So let's see one more example. 1, 4, 5, 6. Let's have a bar of over 4 and 5. So the equivalent would be 1 into 1000. The place value of 1 is 1000. Since it's a bar number, I'm going to subtract. So 4 into 100. The place value of 4 is 100 minus 5 into 10. Since the place value of 5 is 10's place, so I'm going to subtract 50 plus 6. 6 into 1. So it's going to be 1000 minus 400 minus 50 plus 6, making it 556. So the equivalent of 1, 4 bar, 5 bar, 6 is 556. Hypothetically, we do not use these kind of numbers in our day-to-day calculations. That is the reason we call these as bar numbers or hypothetical numbers or negative and negative numbers. So now let's learn how to convert a Winklum number or a negative number to a normal number. So here we have an example, 2 5 bar 6, which means 5 is a negative number. The equivalent of this number would be 2 into 100 minus 5 into 10 plus 6 into 1. Which is 156. Again, this is a tedious process, so we can use an easy method to convert a Winklum number to a normal number. So we always start from the right hand side. If we find a normal number or a positive number, we just leave it as is, and the very first number, the bar number which we encounter, we apply tens complement. We find the tens complement of that bar number, reduce the next positive number to the left by 1. We repeat this process as we move left until you reach the leftmost digit. So here in this case we have 6, which is a positive number. We drop it as is, and the tens complement of 5 is 5 again, and then we reduce this 2 by 1. So this is same as the number we just got, applying the conversion, the place value method. So let's see another example. 3, 4, 5 bar, 6 bar and a 7. So here we have two bar numbers side by side. So how do we start the process? We're going to start from the right hand side. Since the first number is a positive number, we do not do anything. We just drop it as is. And we find the tens complement of the 6 bar. That is the first bar number we have encountered starting from the right hand side. So the tens complement of 6 is 4. Again, we have a bar number. So once if we have another bar number, apply 9's complement to the next bar number. So here, after applying 9's bar, that means we are going to subtract 5 from 9. Instead of 10, we are going to subtract it from 9. So 9 minus 5 gives you a 4. After which we have a positive number. So we reduce it by 3 by 1, which gives you a 3, and then you have another 3. So the equivalent of this number, this bar number, is 33447. You can find out using the place value system also. Let's do that. So 3 into 10 to the power of 4 plus 4 into 10 to the power of 3 minus 5 into 10 to the power of 2 minus 6 into 10 to the power of 1 plus 7 into 10 to the power of 0. So this is giving 3, 0, 0, 0. This is 4000 minus 500 minus 60 plus 7. If you add these numbers, it gives you 33447. 7. Now that we have understood how to convert a Winklem number into a normal number, let's see how to solve a subtraction problem using the Winklem method. Let's solve 38 minus 9 using the regular method and later on using Winklem method. So how do we solve this problem? Since 9 is larger than 8, we borrow a number from 3. So we strike off this, we borrow. So 18 minus 9 gives us a 9, and since there's no number under 2, we just put 2 as is. So the answer to this is 29. So using Winklem method, we do not worry about borrowing like in the conventional method. Instead, regardless of whether the subtrahend is larger or smaller, we subtract the smaller number from the larger number. Again, regardless of whether the subtrahend is smaller or larger, we subtract the smaller number from the larger number. So here the smaller number is 8 and the larger number is 9. So 9 minus 8 gives you a 1. But since the 9 is a negative number, we just put a bar over it. And 3, we do not have any number over here. So 3 minus 0 would be a 3. Now we have a Winklem number. The next thing is we just need to convert the Winklem number to a normal number. So since we have the very first number which we have is a bar number or a hypothetical number, so we find the tens complement of 1, which is 10 minus 1 gives you a 9. And whenever you have a number of the positive number after a Winklem number, you just reduce it by 1. So we get 29. So here there's no borrowing, no messy work. So we have just used a Winklem method, Winklem process to solve this problem. Let's see a few more examples of subtraction using Winklem method. The very first problem, the first example is 765 minus 89. So here my subtrahend, both the numbers in my subtrahend is larger than the numbers above. So the very first thing which I'm going to do is subtract the smaller number from the bigger number. So 9 minus 5 gives me a 4. But since 9 is a negative number, I just place a bar over it. Again, 8 minus 6 is a negative 2. So I just put a bar and then 7. I need to convert this Winklem number to a regular number. So apply 10's complement to 4, which gives a 6. 9's complement to 2, 7. And reduce 7 by one number, which is 6. 676 is the answer to this problem. Let's see another example. 4570 minus 2639. So here we have 0 is smaller than 9, so we subtract 0, 9 minus 0, which gives a 9, but which it's a bar number. 7 minus 3 is a 4, 6 minus 5 is a 1, but it's a bar number, and 4 minus 2 is 2. So now convert this Winklem number to a normal number. The very first number is a bar number, so I apply 10's complement. So 10's complement of 9 is 1. Reduce 4 by 1, it gives a 3. Again I have a bar number, so 10's complement of 1 is 9. And reduce 1 by 2 by 1. So 1 9, 1 3 is the answer for this. Let's see one more example. 7 8 9 4 2 1 minus 4 9 7 7 6 5. So subtract the smaller number from the larger number, irrespective of subtrahend, whether it is smaller or not, it doesn't matter. So 5 minus 1 gives a 4 with a bar. 6 minus 2 is again a bar number. 7 minus 4 is a bar number again. 9 minus 7 is 2, normal number. 9 minus 8 is 1, bar number. And 7 minus 4 is a 3. So now I'm going to apply the 10's complement and then the 9's complement to the remaining 2 bar numbers. So 10 minus 6, 4 is a 6. 9 minus 4 is a 5. I apply 9's complement. 9 minus 3 is 6. Since 2 is a positive number, I reduce it by one number, so it becomes 1. and 10's complement of 1 is 9, and reduce 3 by 2. So 291656 is the answer to this problem. So with this we conclude today's session. Thank you for joining, and we'll continue in the next class. Thank you.